So the first topic we will tackle is about the basic rules of integral. So the first rule is called the constant rule, where the integral of k dx is equal to kx plus c. First example, the integral of 15 dx. Basing on the formula, 15 is the k, so we will just add x and then plus c. That is the final answer. Second example, the integral of 28 dx. So 28 is the k, add x, and then again, always put plus c. That is the final answer. So the second rule is called the power rule, where the integral of x raised to n dx is equal to x raised to n plus 1 all over n plus 1 plus c. First example, the integral of x raised to 7 dx. Based on the formula, we will just add 1 to the exponent all over the value the exponent plus 1. Therefore, the final answer is x raised to 8 all over 8 plus c. Second example, the integral of x dx. X has an exponent of 1, then add 1 all over the exponent plus 1. So, x squared over 2 plus c is the final answer. The next rule is called the logarithmic function rule, where the integral of 1 over x dx is equal to ln x plus c. First example, the integral of 5 over 6x dx. First thing to do is take the constant 5 over 6 out, then integrate the 1 over x, which is ln x plus c, according to the formula. Thus, the final answer is 5 over 6 ln x plus c. Second example, the integral of 3 over 5x. Again, take the constant out. So 3 over 5 times the integral of 1 over x, which is ln x plus c. The final answer is 3 over 5 ln x plus c. The next and final rule is called the exponential function rule, where the integral of e raised to x dx is equal to e raised to kx all over k plus c. First example, the integral of e raised to 3x dx. First is we will copy the given function and then put the k or the constant in the function as a denominator. For this instance, the 3. So the final answer is e raised to 3x all over 3 plus c. Second example, the integral of e raised to 5x dx. Again, first is we will copy the given function all over the k in the function, so 5 in this example. Thus, the final answer is e raised to 5x all over 5 plus c.
Now, we will tackle integration by substitution. If u is equal to g of x differentiable of x, we use this formula. Example 1. The integral of the quantity of x squared minus 4x minus 1 raised to the 4th power times the quantity of 6x minus 12 dx. First, we copy the first term, then factor out 3 from 6x minus 12, which becomes 2x minus 4 dx. So, u is equal to x squared minus 4x minus 1, and du is equal to 2x minus 4 dx. Then, we substitute u and du to the equation, which leaves us with the integral of u raised to the 4th power times 3 du. We move 3 to the front as it is a constant. Then we integrate u raised to the 4th power, so it becomes u raised to the 5th power over 5 plus c. Finally, we substitute x squared minus 4x minus 1 to the equation which we mentioned earlier was our u, and this is our final answer. For our second example, we have the integral of x squared square root of x plus 2 dx. Let u equals x plus 2 and du equals dx. Then, we substitute u to the equation, so it becomes the integral of x squared square root of u du. Then, we manipulate the equation, so it becomes x equals u minus 2. Now, we substitute u minus 2 to the equation. Therefore, it becomes the integral of the quantity of u minus 2 raised to 2 square root of u du. Then, expand the first term, so it becomes the integral of u squared minus 4u plus 4. After that, we apply the radical rule to the square root of u. Therefore, it becomes u raised to 1/2 du. Then, we distribute the second term to the first term. So, u raised to 1/2 times u squared is u raised to 5/2. U raised to 1/2 times negative 4u is negative 4 u raised to 3/2. U raised to 1/2 times 4 is 4u raised to 1/2 du. Then, we integrate each term. So it becomes u raised to 7/2 over 7/2 minus 4 u raised to 5/2 over 5/2 plus 4 u raised to 3/2 over 3/2 plus c. Then, transfer the denominator to the numerator and convert the numerator to radical form. Therefore, it becomes 2 square root of u raised to 7 all over 7 minus 8 square root of u raised to 5 all over 5 plus 8 square root of u raised to 3 all over 3 plus c. Finally, we substitute x plus 2, which is our u, to the equation. And this is our final answer.
Hello, I am Jethro, and now I will teach you the integration by parts. As you can see here, this will be our formula or our guide to solve an equation. Here's the example number 1, the integral of x sine dx. As you can see here, the example have a trigonometry identity. That is why it have a check mark on the trigonometry. First, we will find u, which is x, and dv, which is sine x dx. After that, we will find the du by deriving u, which is dx, and the v by deriving the dv, which will be negative cos x. Next step, we will follow our formula. So it will be negative x cosine x minus the integral of negative cosine x dx. Next step, we're just going to copy the left side and change the sign of the right side. Since there is two negatives, so the answer will be negative x cosine x plus the integral of cosine x dx. Our final answer will be negative cosine x plus sine x plus c. Always don't forget to add the plus c at the end. the cosine x dx changed into sine x because of the rules in trigonometry, that cosine x is equal to sine x. 1, 2, 3. Our next example will be the integral of x e raised to x dx. The example have an e, so it means that it is an exponential. First, you'll find u, which is x, and dv, which is e raised to x dx. Now, we're going to find the du, or the derivative of x, which is dx, and the v, which is e raised to x. First, we will use the formula, so it will be x e raised to x minus the integral of e raised to x dx. Since there will be no other changes that you can do, just copy the answer and add plus c. So the final answer will be x e raised to x minus e raised to c plus c.
This last topic we will discuss is called definite integrals, where the integral from a to b of f prime of x dx is equal to f of b minus f of a. First example, the definite integral from 2 to 6 of 3x squared plus 2x dx. First thing to do is to integrate the function. The integral of 3x squared of 2x dx is x cubed plus x squared. Then, substitute 2 and 6 to the x by still following the formula above. So it will become the quantity of 6 cubed plus 6 squared minus the quantity of 2 cubed plus 2 squared. 6 cubed is 216 plus 6 squared, which is 36, minus 2 cubed, which is 8, plus 2 squared, which is 4. 216 plus 36 is 252. And 8 plus 4 is 12. Subtract the answers. 252 minus 12 is equal to 240. That is the final answer. The second example, the definite integral from 3 to 5 of 9x dx. Again, the first thing to do is to integrate the function. The integral of 9x dx is 9x squared over 2. Then, substitute 3 and 5 to the x, still following the formula. It will become 9 times the quantity of 5 squared all over 2 minus 9 times the quantity of 3 squared all over 2. Now it will become 9 times 25 all over 2 minus 9 times 9 all over 2. 9 times 25 is 225 and 9 times 9 is 81. Since they have the same denominator, we can subtract them easily. 225 over 2 minus 81 over 2 is equal to 144 over 2. 144 is divisible by 2. So if we will divide 144 by 2, it will now become 72 as the final answer.